Everyone can solve the first integral, but can you solve the second one? Okay. So basically, the first one is a well-known integral where you have to use King's rule. Yeah. And if you haven't really solved the first problem till now, I can link the video over here where I have also solved this problem. Now let's go to the second one. How do we deal with this problem? The first thing that we can do is we can basically use integration by parts so as to simplify this log thing over here. So what we can do is if it's integration by parts as this as u, we will have ln sin x times x, so that's x times ln sin x, and then minus this will be differentiated, so we get 1 by sin x times cos x, which is cot x, and now this is free from log, and that's a good thing for us. And now to further simplify this, what we can do is we can basically use the complex definition of these trigonometric functions. Basically we have cos x as e to the power ix plus e to the power minus ix by 2, and sin x as e to the power ix minus e to the power minus ix by 2i. You can use these complex definitions, and that gives us e to the power ix plus e to the power minus ix by e to the power ix minus e to the power minus ix, and then so by 2i, by 2 to cancels out, and we'll have I over here and x dx. Okay. Now first of all, let us use the e to the power minus 2 ix as 1 by e to the power ix, and then let's take the let's multiply here. Let's do those things, and then we will decide what to do next. E to the power 2ix plus 1 by e to the power 2ix minus 1, and then I times x dx. Okay. Now what do we do? After this step, what can we do? Okay, so let's try. This part is already done. Now for over there, let's try y equals to e to the power 2ix. Let's try the substitution. And if we make this substitution, we will basically have dy equals to e to the power 2ix times 2i dx. This is y itself, so dy by 2iy is equals to dx. Fine. Now let's try, and also x is ln y by 2i. Yeah. Okay, now let's use this substitution. That gives us x ln of sin x minus integral of y plus 1 by y minus 1, and then what do we have? I times ln y by 2i, I times ln y by 2i, and then dx is dy by 2iy. Okay, that's nice. Now 2i times 2i is minus 4, and minus 4 times minus is a sign is plus 4, so plus 4, and also we can take the I outside, so we have integral of y plus 1 by y times y minus 1 ln y dy. Yeah, I think we are going in the right direction till now. Oh wait, no, we just made a mistake. This is I by 4. Okay, so now we can use partial fractions. So from partial fractions, we want to see how we break this expression y plus 1 by y minus 1 into two different fractions, a by y plus b by y minus 1. Now there's a cover-up rule, or we can also go normally. You can just take the LCM and write it as a y minus 1 plus b times y. Now if we substitute y equals to 1 over here, you get 2 equals to b. If we substitute y equals to 0, you get 1 equals to minus a, implies a equals to minus 1. So you basically have a equals to minus 1 and b equals to 2. So that's why we can write x ln of sine x plus I by 4, now minus 1 by y, so minus ln y by y, and then or 2 by y minus 1, so 2 ln y by y minus 1 dy. Okay, cool. Now you have x ln of sine x. Now if we differentiate this, we will just have, if we can let g as ln y, and then 1 by y dy will be dz, so that will just be g square by 2. So this will just be ln square y by 2. Yeah, and over here this is I by 2 and the integral of ln y by y minus 1. Oh, okay, so we have ln y by y minus 1. Now how do we deal with this? How do we deal with this? Dy. Okay, so for this one, how we can deal is, we can, if we basically there's also a common approach. If we have ln y by 1 minus y, what we can basically most of the time do is, first of all, use integration by parts, and due to that, in the second person we will have ln y 1 minus y by y. Yeah, this differentiated integrated, and also a minus sign over here. And now we know that this is just li2 of y, so we can use this way. Like I will show you how we can use that over here as well. Yeah, let's proceed. X ln of sine x, yeah, minus, now I by 8. Now this is ln of 2ix, yeah, that's why this is 2ix whole square, and plus I by 2 over here. I can write this as ln y and then ln of 1 minus y. Yeah, basically I can write this as 1 minus y times minus 1. So if you integrate that, we get this thing, and then minus I by 2 integral of ln of 1 minus y by y. Basically differentiate this and integrate this thing over here, dy. Okay, I think so. Now it's easier to proceed. Yeah, x ln of sine x, x ln of sine x minus, basically now I square is minus 1, so minus minus plus, plus ix square by 2, 4 cancels out, and then plus, now this is y is 2ix, so we have this e to the power 2ix, so ln of e to the power 2ix is just 2ix, 2 cancels out, and so this is just minus x, and then ln of 1 minus e to the power 2ix, and plus I by 2, and this is just li2 of y, and we know the y is e to the power 2ix. I'm extremely sorry for the disturbance from the here. Plus c. Okay, so now I think this should be the answer. Now what you can do is, I'm really sorry, what you can do is to check the answer. I already have the answer over here. So x ln sin x, and then ix square by 2, I li2 to the power 2x by 2. Let's see. Yeah, ix square by 2 plus I li2 e to the power 2x by 2. X ln sin x, and this thing over here is minus x ln 1 minus e to the power 2ix. Let's check. Minus x ln 1 minus e to the power 2x. Okay, so this is the correct answer, and I hope you got the solution and thought process as well. First of all, this is just we are just trying to simplify using to remove log, and then we converted to the exponential form, and we made a substitution, and then used partial fractions, and then this is also a standard idea, and we solved the problem. So hope you enjoyed this one. Thanks for watching. Look forward to seeing you in the upcoming videos too.